Hello, my name is Nigel Griffiths, who work in Power Systems Advanced Energy Support in Europe. In this Nmon for AIX Starter Pack movie, we'll be looking at the data capture ready for later analysis. I see Nmon as coming in three different flavors. We'll be focusing on this one, the Topaz Nmon, but there's the older classic version, and then there's Nmon for Linux. Completely different source code, but much the same sort of function. By the current versions of AIX, I mean after these particular versions, that's when Nmon was built into AIX itself. The older versions come in Nmon 11 and 12, and they'll be running on these older versions of AIX. People tend to only do data capture for these older machines if they're now thinking of moving these workloads to a newer computer, a newer version of AIX, and they want to capture how busy they are and sizing information. There's also the Nmon for Linux on the different platforms and appearing in many distributions now. One at the top in here was the one that I wrote for 12 years in my spare time, supported by me. The Topaz Nmon now is part of AIX, installed that way, and it's supported by IBM as any of the other regular AIX performance tools. The Nmon for Linux, I'm still supporting that, and it's appearing in the IBM online web repositories and even in some distros now. So concentrating on the data capture mode now, this is an alternative to the live on-screen mode of interactively looking at what the computer is doing right now. That's in a different movie. We're going to capture the same data and a whole lot of config information into a file, and then we're going to later run tools for graphing and analysis of what's going on. The Nmon output file is a simple text file. You can edit this with any editor, for example VI, and see all the data. It's actually a comma-separated values file, so CSV. If you run the file through the sort-n command, then you can actually pull that straight into a spreadsheet, and then you can start graphing the information. The sort is only there to get the data in blocks of similar sorts of data, the CPU in one block and the disks in another block, network in another block. Most of the down-level tools that do the graphing and analysis don't need the sort operation. So let's capture this data for later analysis. It's nice and simple to do. We're just going to use the nmon command. The -f has to be the first option on the line, and that means go file save mode, and that sets up a whole load of parameters. Then we're going to overwrite some of those parameters with things like the number of seconds between captures of data. In those gaps in between the captures, Nmon actually does nothing. It just sits sleeping in the background. And then we say how many of those captures we actually want, and that's it. That's all you have to tell Nmon to get it to capture the data. Now listen carefully, because the next 3 points are important. If you want to make a nice detailed graph, aim for 300 to 600 data captures. Each one of those captures will be a point on a graph, and with a modern screen about 1,500 pixels across, you can't have more than 600 points. Each of those will be 3 or 4 pixels each. So there's no point in having Nmon files with 10,000 data captures, because you can never see the details on any screen that I've ever seen. Next up, the output file is in the current directory, and it will be named like this, hostname date time. This is important, very carefully chosen by me so that you can actually find the right host and then the right date for your Nmon data if you've got a directory with hundreds of files in it. Nmon, once running, will actually disconnect from your terminal. It becomes a daemon process. Many people assume it's crashed. Thank you very much, guys. But it's actually still running in the background. It's protected you from logging off and Nmon stopping, as your normal program would when you log off. You can go and find it with a ps-ef grep nmon, and you should find it there running along in the background. So how do you calculate these seconds and number of captures? Here's 2 examples. If you want to capture for a busy hour, then we have 60 minutes and 60 seconds, so this is the length of the time we're going to run the data capture for. If we say we want 10-second intervals, then that will give us 360 snapshots. That's a good set of number. So all you do is type in nmon -f minus 10 seconds and 360 captures. Off you go. If, however, a lot of people like doing all-day captures, then it's 24 hours times 60 minutes times 60 seconds. It's actually quite a lot of seconds in a day, isn't it? So if you want to then capture that at a sensible interval, then if we do 5-minute intervals, that's 300 seconds, then we have 288 snapshots. And so nmon -f, 300 seconds, 288 captures. Now you could go down to 2 or 3 minutes down in here and boost this up, try and, if it goes to 720, well, okay, you can probably squeeze that onto a graph, it's okay, but try not to go any higher than that. A lot of people run Nmon on every single AIX copy every single night, then they know they have the data to have a look at later on if they need to. So you might use the cron to do that. This is an example here. So we got 0 minutes past the 0 hour, so that's midnight. Any day of the month, any day of the week, and any month. And then we're going to run the Topaz Nmon command. I'll cover the -t and the -n option in a minute, but you can see this is giving a directory where to put the files. An alternative is you can use the Smitty Topaz options, and you follow your nose with start new recording, persistent local, and Nmon format. Then you give you a whole bunch of options that you'll recognize are the Nmon options, and the default place where the data go is varperf daily. Now, very quickly, I've typed in Smitty, then we've gone to performance resource scheduling, Topaz, start new recording, start persistent local recording, choose the format as Nmon. And then we get the parameters in here. We can change our options and hit go, and then we'll get our daily recordings automatically set up and saved in that directory. And it does some housekeeping so it won't fill up the file system with hundreds of files. Before a quick little demo, we'll have a look at some of the advanced options. These will probably cover 99% of the times when people actually run Nmon. So the -m, it allows us to specify a directory where the data will go. This is useful if we're starting Nmon via cron or via a script. The -t option also collects the top processes. The capital T option does the same, but also captures the command line arguments. There's some things like relational databases where all the processes have the same command name, and it's the options that tell you what it's actually doing. By default, Nmon ignores processors using less than 0.1% of a CPU. This is to keep the size of the data. We don't really want to capture lots of information about processors that are doing nothing. But we can, if you want, to reduce that ignore factor down to a lower number. In this case, it's 1/1000th of 1%. -N will add the NFS stats. That's good if it's an NFS server, for example, or you know you're using NFS client to do some of your work. We also have fiber channel stats. That's the little caret sign. We have the -at for the WPAR stats. The -at is used with the WPAR commands as well. Then the final one is the VO server C stats. The capital S was already in use, so we use capital O. I think of ocean, so an ocean is a bit like a sea, so that switches on the C stats. So here we are on AIX 7 to EL3 Service Pack 4, and I did a quick PS-EF looking for grep. Somebody else is already running Nmon to the screen, and so we're just going to start up Nmon. We use the -F to put it into file, T for top processors, -S5 seconds between snapshots, and we'll do 60 of those. We'll have 5 minutes. So this will be a very small capture, just an example, and it's going to be an extremely boring demo because it's going to sit there, does some checking that it's going to run okay, and then drops itself into the background. It looks like it crashed, doesn't it? But if we run this PS command again, we'll find there's another Topaz sitting here. Here's our parameters, FTS5C6. It's actually, because it's using the Topaz Nmon in the background, it's added some extra parameters that it's defaulted in for itself, the directory and the start time. But off it's gone, and it will sit there for 5 minutes and stop. Now if we clear the screen and we just list the files, we can see here is a host name in here. This is the data I'm actually creating the movie. There's nothing I can hide about that. And it's 8:55 in the evening. Here's the Nmon file. If we have a quick little look in that file, we can see it will put some header information in. It's now collecting some more data as we wait. So here we can go. we can see this AAA already as Topaz Nmon in it. This is good. If this had Nmon 11 or 12 and it wasn't a very old copy of AIX, then we're using the classic Nmon when we should be using the Topaz Nmon. I'm going to not make you watch this screen for 5 minutes. We'll come back in 5 minutes and have a look at that output file. Okay, I've performed various tasks while that's happening to make sure that we have some sort of numbers in here, stats, rather than a completely idle system. I actually worked out who that other Nmon user is. It was me! I left this running from a previous recording, but okay, let's put that aside. Make this window a little bit bigger, and we'll just go and have a look at that Nmon file. Here's our file here. We can see it is 400k, not too big, and we can edit that file. So at the top in here we have we can see all these comma separations in here of our data. So some things are strings and some things are numbers in here. The first little bit is the AAA records. This tells you about the capture, what machine it was on when it started, what the parameters were, and those sorts of things. Then we have a whole set of BBB sections, which is the configuration data. This first thing in here is this first label, if you like, is to make sure that the file sorts properly, so we get the various sections broken out like this. And I don't want to go through lots of detail in here, but we have a whole set of commands are run and the data captured. So it's actually a good way of documenting the configuration of your machine as well as the performance data. So there's a whole lot of things in here. Then we're going to have these are what's called the header parts. So this is the CPU all and what the columns are. The data will be further down, and that includes all the virtual and logical CPUs. Here we have memory use and things like this. Further down here, this is all the header files. Then there's some more BBB sections. Lots of lsconf command is there. L-stat minus I, lots of useful things in there, and we want to go down until we get to some real data further down here. In fact, I can search for the bit I'm looking for. It's a ZZZ file. So this is the first data capture going on here. This is timestamp 1, and this line is telling you that this timestamp 1 that you can see is using all these other records were taken at this particular second on this particular day. Then you can see there's a lot of zeros in here. Oh, I've got some data going on in here that can be useful. We can go back in here. So here we have all sorts of bits of information in here. Also, if we go to the end of the file, we'll find there are some bits of the configuration that are recollected at the end, particularly counters that may have changed as we actually ran. So we can see a before and after image for some of those counters. Well, that's it. Now we need to put this data into a tool to draw some graphs and then have a look at what the machine is actually up to. Once you have your Nmon data, you probably want to look at it and graph some of the data to get the interesting facts out of it. And this is my food chain diagram for Nmon in here. We've seen it can output stuff on the screen. We can also get the file with the -f option. Various things we can do. We have an Nmon consolidator that can take multiple Nmon files and produce your set of graphs. We have the Nmon analyzer from Stephen Atkins. This is by far the most popular way of analyzing the Nmon data. He uses Microsoft Excel to actually generate the graphs in great detail. Some other tools like Nmon to Web and Nmon to RRD. This transforms the Nmon data and generates input scripts for the round-robin database tool. Databases. From that, then we can generate GIF images that you can put onto a website and look at it via your browser. Federico has a pgraph tool that uses dynamic Java, so it lets you zoom into big Nmon files. And the new one is that I'm working on now is Nmon chart. This actually creates a web page and then gets your browser to do the heavy lifting to create the graphs on the fly. Well, that's enough from me for this little movie. You can find me on Twitter as Mr. Nmon. You find lots of movies from me on YouTube. I've got an expert blog, and there's 2 virtual user groups, excellent places for lots of material and information about running AIX and power systems. If you've liked this movie, why not click the thumbs up below?